Welcome back. Finally, I've finished this video of the series and it will probably be the longest part in the whole series, where we'll be creating a system for picking up specific items that make noise when thrown, so that the enemy will head toward the sound to investigate. We'll also create a custom throwing widget, just like the ones we see in popular games we talked about before. For those who want to see a full preview of what we're building today, I made a short 2-minute video on the channel showing everything. But don't worry, nothing here is too complicated. Even if you haven't watched the previous videos, you'll still be able to create this system since it's a bit separate from what we covered earlier. However, I strongly recommend watching the earlier videos of this series, especially since we built different and advanced AI systems there as well. So without further delay, let's begin. First, as usual, let's prepare the systems we'll be building. We'll start by creating a new folder called item_throwing_tools, and inside it we'll create 4 subfolders: item_data, item_assets, item_actors, and item_widget. Now let's prepare what we need. Inside item actors, we'll create a new actor called master actor throwing. And from it, we'll make 2 children. The first named IT bottle jar glass, and the second named IT_tin_food_box. Before we continue, in item assets, we'll create 2 folders, one called static mesh item and another called item effect. Inside static solid mesh item, we'll import the items we'll work with, the static meshes, and the materials. I'll put them in the description for download. That's what we'll use here. Then inside item effect, we'll add some images and sounds we'll need later, and I'll also add them to the download link in the description. Now that we're done here, let's go to item data. First, we'll add an enumeration and name it item name. Inside it, we'll add 2 entries: bottle_glass and tin_food box. After that, we'll create another enumeration the same way and name it item type with 2 entries as well: glass and box. After finishing that, we'll add a new structure blueprint and name it item_structure. Inside it, we'll add 4 variables. 1. A reference to master item throwing, the one we made earlier. 2. An integer named current stock. 3. An integer named max stock. 4. A reference to the item type enumeration. That's everything here. Now let's create a data table. But before we do that, here's a quick explanation. A data table is simply used to store organized data in table form based on a predefined struct, like the one we just created. It makes managing and retrieving data inside the game much easier. So, to create it, search for data table, click it, and in the pop-up window, choose the item structure we created earlier. Inside the table, you'll see the variables we defined in the struct. What we'll do now is add 2 new rows. Each row represents an item that we'll throw in the world. Important note: The names of the rows must be exactly the same as the ones in item name, otherwise it won't work. So we copy and paste them here. Now let's fill in the data. For the first item, bottle glass, in item class, set it to the actor we made earlier, IT bottle glass. In current stock, leave it at 0. In max stock, set whatever value you want. This will determine the maximum number of this item the player can carry. In item type, set it to glass. For the second item, do the same. Just change the item class and item type to box. And that's it. We're done here. Before moving to the next step, we'll create a new game instance to store some variables and also act as a mediator to pass variables around. In this case, using a game instance will be more effective than using actor interfaces. Trust me, this comes from experience. For the game instance to work, there's one extra step. Go to Project Settings, search for Game Instance, and in that field, assign the GI game we just created. Okay, now we've finished all the boring setup in our project. Let's move on to the fun part. In the next step, we'll start building the logic for picking up the items that we'll be throwing. So quickly, let's head to master_item throwing. The first thing we'll do here is set up our actor. We'll add the static mesh, sphere, and billboard. I'll slightly adjust the size of the sphere here, and as for the billboard, we'll go to where we previously placed all the images and take the white circle image. Let's use that as a billboard image and resize it to suit us. That's all for now. Now, in the event graph, we'll first get a reference to our character. And yes, I'll also change the name here to the item. After that, in the sphere, we'll bring in the two events, onComponent begin overlap and onComponent end overlap. And in both events, we'll make sure that it's the player who is interacting with it. Now, simply, if the player enters the range of the sphere, we'll show the billboard, and if they leave, we'll hide it again, as an indication that this item can be picked up. We'll also create a Boolean variable called playerIsIn, which we'll need later. For now, I'll just add a cube for testing and adjust things a bit to get a better shape of what we want. After that, before testing, we'll create a custom event called REST_billboard, the goal of which is to make it easier to modify the billboard, especially since we'll need it later. Inside it, we'll add two Boolean variables, rest and icon full. The idea is this: when we already have the maximum number of items that can be picked up, we want to show a sign indicating that our inventory is full. As usual, you'll find all this in the attached image files. As for the rest condition, we simply want to know if we're going to rest the billboard. If yes, we'll show the white circular dot again, and if not, we'll show an icon that indicates we can pick up the item. You can choose whatever you want for this since I didn't assign a specific image. Before we finish, we'll place rest billboard here and activate the rest option. Okay, let's see. The current look of the world doesn't really appeal to me, so I'll edit it a bit. You can skip this part as I'll also fast forward it. Alright, much better. Let's do a quick test of what we've done. Good, but I'll make one last adjustment to the world. Yes, that's better. Back to what we were doing. As you can see, the logic is working well. Now, for the next step, I'll remove the changes from our parent actor, since we don't want the child to inherit them, and I'll make it look better. Of course, I'll also delete the parent from the world. Now let's start preparing the child to place them in the world. The static mesh that I'm adding here is the one we imported earlier into the engine. I'm not really doing anything here except adding it to our actor and adjusting its position. I'll also scale down the billboard to make it smaller since its current size looks too big to me, especially since our items are small. Same thing here for the tin food box. Also, a small note to avoid errors. Make sure the collision complexity is set to project default. Then it's best to delete the current collision and add a new one. A simple capsule collision. Same thing for the glass bottle. Alright, we're done here. Let's place them into the world now. No issues here, which is good. When I move away, the white dot disappears, and when I get closer, it appears again. For the next step, we'll make the interaction work only when looking directly at the item through the camera. To do that, let's go to our player character. First, we'll create a new custom event called trace item. What we'll use is sphere trace for objects, and since we only want to follow the camera's rotation and not its location, the starting point will be the player's location, but with a different height, which we'll set to 80 for now. Then we'll call actor location again, and since we want the camera's rotation, we'll use follow camera, get world rotation, get forward vector, we'll multiply it, then add it to actor location. We'll convert the result into a float, set it to 400, and before plugging it into the end, we'll do one last split and change the height to 200. We'll set the radius to 20 and keep it at 1 frame. Let's test it. Nothing is showing. Right. As always, I forgot to add it to the event tick. I always make that mistake. Alright, now it shows, and as you can see, it follows the camera exactly as we want. Next, we only want it to interact with our items that will be thrown. So we'll add a new object channel and name it item throwing. Now, let's refresh the nodes and add the new object type we created. Of course, we'll also go to master item throwing and change its object type to item throwing. To be sure everything works fine, we'll do a quick test. Yes, it works perfectly. When you look at the item, it displayed the item's name. Now we'll delete this part and create new variables. The first one, item info box of type item structure as an array. The second, item info glass, same type and also an array. The last, overlapping item, which will be a reference to master item as an array. So first, we'll check if overlapping item is empty. If it is, that means this is the first time we're looking at the item. Then we'll do cast to master item throwing and create a variable from it. Before continuing, let's quickly return to master item throwing and create a variable called item name, referencing the item name we made earlier. Then, in the construction script, we'll fetch our data table. We only want to retrieve a specific entry from the table, not everything, and this will be done using item name. The result will be the item's info, which we'll store in a variable. The last and most important step is adding the item names in each child with its own item name. Now, back to the player character to continue our logic. From master item throwing, we'll get item info, then split it. From item type, we'll do a switch. So what are we doing here? It's simple. If the picked item is of type glass, we'll check from item info class whether the current stock is less than the max stock. And we'll do the same logic for box type. After that, we'll make sure the number of overlapping items is less than or equal to 0. If yes, we'll add it to the array using add unique, and we'll use the reference to master item throwing for that. Then we'll call rest billboard and leave it without checking anything, which means we can carry the item. Alright, the next step is if the item we want to pick up has already reached its max stock in our inventory, then we won't be able to carry it and the rejection icon will show. We'll just activate the icon full flag. Before the last step, we'll check if overlapping item isn't empty. Here we'll check for master item throwing. If yes, we'll rest it and clear overlapping item. Finally, if we're not picking up any item at all, we'll make sure to clear overlapping item and copy the same logic as above, pasting it here. Let's test it. It works well without issues, but the pickup logo looks too small and I don't really like it, so I'll adjust it. Alright, I'm back. I made a simple logo for pickup, as you can see. Make sure to place it here instead of the old one, then let's test again. Yes, as you can see, when I look, the pickup symbol appears, and when I move the camera away, it disappears. Let's test it now without any draw debug. Yes, it's really great. As for the range, as you can see, maybe it's a little too much, but we can easily reduce it. However, be careful. If you only reduce this value here, you'll get this error. Let me show you more clearly. The idea is simple. When you reduce the value here, you must also reduce it in the extra height value here correspondingly. But to make things easier, we'll make it a variable. We'll multiply its value by 2 and place it here, while keeping the original as the extra height. Let's test. Good. I'll make some tweaks until we find the best value. Okay, I'll settle on this value. Next, we'll work on the actual pickup logic. We'll add a custom event called check stock and pickup. It will have two variables, the first item info from info structure, the second item reference from master item throwing. What we'll do first is check the item type, glass or box. Then we'll check if item info glass is empty. If it isn't, we'll first check if we have space in the inventory, same as before. Then we'll do set array element, split it, and add all variables as they are except current stock. We'll fetch it, add 1, and then pass it back in. Finally, we'll do destroy actor. We'll add print string just for clarity. Now, if item info glass is empty, that means this is the first time we take this item, so we'll just add it. For current stock, we'll add 1 and pass it back in with destroy actor. We'll copy this same logic and paste it here, but change item info glass to item info box. That's it here. Next, we'll assign a key to be the pickup button. Before pickup, we'll make sure master item throwing is valid. Then we'll create a variable called cItem and place it here and here. Before running the pickup logic, we must confirm 2 things. 1. The player is actually inside the sphere. 2. They are looking at the item. The input for item info will come from master item throwing and item ref as well. Let's do a quick test. Yes, it works. But for a better test, let's place more than 1 item in the world. As you can see, looking at the item works, and when the stock reaches the max, the rejection icon appears. For the metal boxes, it's because I set the max stock to 5. Now, as you can see, it works smoothly with no problems. So our next step will be to display our data and picked items in a special widget, like the one that appeared at the start of the video. So quickly, let's create a new widget and name it UI_throw_list. Not the best name, but let's move on. First, we'll add 2 canvas panels. For the second one, we'll set the anchors to full and reset all the offsets to 0. Then we'll rename it to wheel panel. Inside it, we'll add 4 buttons. It's very important to set the alignment to 0.5 and the offset to default for all buttons. Then at the bottom, exactly at transform angle, we'll set it to -45. This is important. So let me give you a quick explanation of our idea here. Right now, we're aiming to create an internal wheel to act as our inventory. But since widgets in Unreal work with rectangles only, this is impossible. So we have 2 options for creating a circular wheel. 1, using material, but believe me, that's long, complicated, and I hate it. 2, the second option, which I came up with myself and prefer, simply creating a wheel divided into 4 sections, each with a 90-degree angle. Then, to combine them together, I'll build logic inside the widget to arrange these elements circularly on the same axis. This will give us an amazing interactive circular wheel without any complicated materials. Plus, later you'll be able to modify it however you want, with infinite possibilities to create whatever shape you like. What I show in this video is just one example of the many ways this system I invented can be used or even improved further. Alright, back to our topic now. The next step is to place the images in the buttons. And for the images, make sure to place them in the correct order as I show you in the video. This is very important. Also, make sure to set draw as arrow image for each button. That's important too. We'll rename the key buttons we'll need later. Finally, make sure to set wheel panel as is variable. In the event graph, at event construct, we'll show the mouse cursor and set the focus on our widget. Then, we'll immediately build the logic of our wheel. We'll create a custom event called position item on circle. The first thing we'll do is call setRenderTransformAngle from wheel panel. From the angle input, we'll create a variable called rotation wheel. Then we'll look for a for loop and create a variable called item index. It will represent the number of items in the circle. From wheel panel, we'll get getChildAs, connect it to the for loop index, then fetch slot as canvas slot. After that, we'll check is valid. If yes, we'll fetch 4 values from it: set size, set alignment, set anchors. We'll organize them. For insize, we'll create a new variable called uniform size. Same for alignment and link it, same for anchors. For the fourth one, set position, we'll split it and start building our logic. From index, we'll multiply it by the result of 360 divided by item index. Then add it to a new variable called start angle. Then we'll convert it from degrees to radians, and from that get cos and sin. We'll multiply both by a new variable called radians, and after connecting them, we'll plug them into set position. Yes, that's all. Now we'll connect it to event construct. Before testing, let's adjust the variables we made. First, item index, which represent the number of items in the circle. We have 4 buttons as you can see. Set it to 4. Uniform size, 400, represents the wheel size. Alignment, 0.5. Start angle, -90 radians, 280. To test it, we'll build simple logic in the player. When pressing a certain button, we create our widget and add it to viewport. At the start, we'll check if our widget exists. If not, we create it. If yes, we check if it's open in viewport. If it's not, we open it. If it is, we remove it with remove from parent. Of course, we'll also hide the mouse cursor and remove focus from the widget. That's it. As you can see, our widget has already taken shape. Before moving on, let me show you the benefit of the variables we made. For example, if we play with the rotation wheel and set it to 45, you'll notice the wheel's rotation changes. You can set it however you like. I'll leave it at 45. As for uniform size, it's different. If you change the size carelessly, this will happen. The widget will grow but overlap since you must find the right balance between uniform size and radians. To give you an idea about radians, it changes the distance from the axis. The bigger it is, the farther away, the smaller, the closer. Alright, but for now, we'll leave it as it is. Now we'll add a text called text_stock and set it as variable. Next step, we'll call onHovered and onUnhovered for all our buttons. Don't worry, there isn't much work here. We'll tidy them up a bit. Before we start, we'll set the opacity of the wheel to 0.7 and create two new variables, wheel opacity 0.7 and zoom index 1.1. So first, we'll take a reference to the button that the mouse cursor hovers over. From it, we'll call slot as canvas slot, then call three values, set size, set Zorter, and set render opacity. We'll set Zorter to 3, render opacity to 1. For size, we'll simply multiply uniform size by zoom index, that's all. Now, for unhovered, we'll copy the same logic but revert the size to normal and restore the opacity to its initial value. We'll apply the same to all buttons, just changing the button reference each time. Let's test. As you can see, when hovering the mouse, the button grows, and when not hovering, it shrinks back. But I don't feel satisfied. Something feels off. Let me fix it. Yes, I think I figured it out. Instead of changing the opacity of the entire wheel panel, we'll change the opacity of each button only. Let's test again. Yes, much better. Works perfectly when I click and hover. No issues here. What remains now is showing how many items we have in the inventory. So first, we edit the text to be centered with the same settings we used for the buttons. I'll add an outline to make it clearer and increase its size a bit. I'll also move it up a little. That's it. Now we make sure it's hidden. Next, we do two things. First, get a reference to our player character, and second, get a reference to the game instance we created earlier. Let's expand the area a bit here. In the button glass logic, we'll get the item info glass variable from the player character. We check if the stock is 0. If it is, we set the text to 0 and show the text. If it's not 0, we set the text to our current amount alongside the total using an append node. We copy what we did here and reuse it, but change the text to 0 and hide it when appropriate. We do the same for button box. Changing only item info glass to item info box. For the other buttons, we copy only the logic for when the mouse is not over them and leave the rest as is. Let's test it. Good. The text shows correctly when I hover and when I unhover. Now, let's try to pick up an item. Yes, our inventory changes accordingly. Great, here we've fully finished the pickup system. Now, before we completely finish our widget, there is one additional thing we will do. Each time I click on the box or glass button, the item I clicked will be stored, so we can call it later when pressing the throw button to know which item we will throw. To do this, we go to the game instance and add a variable called item type selected of type item type. Simply, when you press the glass item, we choose glass, and when you press a box item, we set box. Easy. On click, we remove the widget and hide the mouse cursor and remove focus from the widget. That's it. And with that, we have completely finished this part. The next part is building our throwing system and the throw trajectory in which we will throw the item. To do this, we first go to the player character where we will build our next system. Now we will create two custom events. The first one we will call drawPathThrow and the second update throwPath. In drawPathThrow, we will add a set timer by event, set it to 0.01, and enable the looping option. After that, we create a variable from it called timer, and we connect the output of the event with update throwPath. That's all for now. Before we continue, there are two things to do. First, let's quickly create a reference for the game instance. Second, we create a new static mesh and call it throwable, place it inside the character's mesh, and also add a projectile spline to it. As for throwable, we will set its parent socket to handwrite, and also put inside it a static mesh of the bottle just for testing and searching for a good angle. It's better to stop the animation for a while to find the best spot. In the end, we make sure it's set to hidden in game, and that's all. Now, we go back to the event graph and add a new button. Choose whatever you want, as it will be the button that starts the throwing process when pressed. When pressed, the first thing we add is do once, then we call type of item selected and perform a switch. Our logic will be simple. If the total number of items we have is not equal to 0, that means we can throw. Then we decrease one item from the inventory. Then change the throwable static mesh to the item we are going to throw, which of course is the item itself. We get it from item class using getActor of class. Then we call drawPathThrow and make throwable visible. After that, we create two new variables, one called prepare to throw and the other not in stock, and connect them with what we built. For the box, we will do the same thing, only changing it as usual through item info. That's all. Now, when we release the button, we perform a check. If we don't have the item, then we reset do once. If we do have it, then we execute do once and create another new variable here called throwing. The first thing is that we hide the throwable, then we use spawn actor of class where the location and rotation will come from throwable. And the class will be determined based on the selected item type from the widget using a simple select node. After that, we get the item from here and add impulse to it. We want the throwing direction to be aligned with the camera. So we get the forward vector of the camera and put the X and Y values into it. While for the Z, we apply a map range clamped with values from 0 to 1, map to 3 to 10, multiply it by 150, and then connect it. We add set actor rotation to rotate the player toward the throwing direction, then clear the timer variable, and after a 0.5 delay, we turn off our variables. Finally, we reconnect it with do once. One last thing, in case our item count is 0, then we won't be able to throw, and after that we reset the second do once. Yes, I know I made a mistake. We should have connected this with the first do once. And with that, we are done here. Now, let's move on to the throwing path logic. In update throw path, we add a node called predict projectile path. Make sure to change its settings as I do because that is important. After that, we set the start location of the path and then the force we will apply, and we will simply copy what we created earlier. Now, let's just quickly make sure that the thrown items have physics enabled. After that, the last step before testing is to add a throwing animation. I've already created one and will leave it in the description. First, we create new variables for the ones we created in the player character. Then in the unim graph, we search for layered blend per bone and blend poses by bool, which I already explained in a previous video of the series. And here we will set the condition prepare to throw. Here we will add clavicle, right? Since it's the arm we will throw with, we connect the main state here and another copy of it here. In the true pose, we create a new state machine. Inside it, we add the preparing to throw animation, then another state for the throw itself where we put the throwing animation. And the condition between them will be throwing. Good, now let's test it. Okay, this is worse than I expected. Wait a moment, I'll fix the problem and come back. Okay, I'm back and I know where the issue is. First, we need to make the two items here movable. That's important. Then we need to make sure mass is enabled for the master actor throw. It's fine to leave it at its default value. After that, we will only pass the Z value here, and the last part is changing spawn to default. That should solve the problem. Now to test it, first we pick up an item and then... Good, as you can see it actually works. This is amazing. The path is being drawn and the item is being thrown along the path without problems. So let's continue with the rest. Now we create a break here, and from the path data we use A for each loop, where we will use the projectile spline only. It seems I used the wrong spline component, so let's quickly change it to the correct one. After that, we call add spline point and take the position from another break here. And we set it to world. In the completed pin, we add another for loop where the last index will be the number of points in the spline, and then we add spline mesh. After that, we create a new variable and make it an array. We then add to it here, and the last thing is to look for set, start, and end. Simply, from the projectile spline, we search for get location and tangent as spline point. The point index will come from the for loop and we connect it normally. For the endpoints, we will make a lerp vector with alpha set to 1 before connecting them. And don't forget to add +1 here. The next step is to add a new custom event and call it clear throwing path. In it, we will simply destroy the spline mesh, clear all its values, and also clear the spline points. After that, we add it to these places. The last step is to add a static mesh here that will form our path. So we create one in the world as a simple small shape to fit our needs and make sure to remove any collision from it. After that, we change its name here, copy it, and paste it here. However, there's something special here. Each spline mesh requires a material with specific settings to work. So let's create a new simple material. Inside it, I will make it translucent and add only a white color, connect it to opacity and base color, and then most importantly, without this it won't appear. Search for the option called Used with Spline Mesh and enable it. That's all. Then we apply the material and also make sure it's aligned to the Z-axis and disable the debug here as well. Now let's test it. As you can see, I cannot throw until I pick up an item, and when I want to throw, the path is drawn exactly as we want. Also, I cannot throw if my inventory is empty, so everything is working well. Now there is something I want to add, which is to make the final point where it collides with the ground display a shockwave effect as an indicator of the impact location. To do that, first we need to create a new material and call it wave effect. We won't do anything too big here. I'll set it to translucent and unlit. And I'll use the radial gradient exponential node with time. After we finish here, we create a new plane, apply the material we created to it, and remove any collision from it. In our logic here, we use add static mesh and put the plane in it. Then convert it into a variable called static mesh target. We set it to no collision and define its location in the world simply by taking it from the hit result. After that, in clear throwing path, we check if it is valid, and if so, we destroy it. That's it. Good. Now we have completely finished this part. The next and final part is to make the thrown items act as a distraction for the enemy AI. To do this, we go quickly to the AI controller and here we add another sense to the AI perception, which will be AI hearing, and set its hearing range to 1200. The next step is to add a custom event and call it move AI to sound location. And inside it, we create two new variables. The first called to sound location and the second is hearing sound. After that, we add a do once set to sound location to true, then use AI move to. We also stop any animation montage, and when the AI reaches the sound location, or even if it fails, we set is hearing sound to true. Then we add a delay to represent the time it spends searching. After which we return it to the previous path and set all the variables to false. The next step is to copy the AI perception site, rename it, and place it in the graph. What we will change first is the AI sense class. After that, we want to ensure two things: that it is not already chasing the player and that it does not move toward every sound in the world, because that would be completely illogical. So we will make it move only toward sounds that have a tag called enemy. After that, we raise the alert level and make it move to the sound location. One last thing remains, which is to add some conditions to our logic to prevent certain errors from happening. Just follow what I show in the video. After that, finally, we add the searching animation. We go to AI Manny. and simply do the same as before. We bring in is hearing sound and make it a variable. Then here we add a condition. If it is hearing any sound, then yes, we make it play a searching animation blended with its main movement through the spine 0-1 bone. Alright, now let's move on to the throwing items we created earlier. We'll be working on two things. The first is adding sound, and the second is adding a tag to them so the AI knows this is a sound it should hear. So first, in the tin food box, we make sure that generate hit event is enabled. Then we bring in event hit. What we want is for every collision to trigger a sound, but we also want it to stop if there isn't a real collision. So we check if it's in the air or not, using a line trace in a new custom event, and we also use getComponentBound to check this. We create a new variable to name it in air and put it here. And in event tick, we go back to event hit. We want every collision after it has been in the air to play the sound once at the point of impact. Then do a report noise event to notify the AI about the sound location. And after a small delay, we reset it back to do once. And if it's not in the air, meaning it's on the ground, we want it to play the sound once too. In the same way, the reset logic is different. We create a custom event and connect it here. Then we call it here. And the last step is to add the tag named enemy. Done here. Now we move to the glass bottle where things are a little different since we want it to break on impact. So first, we create a fracture for our bottle. First thing, we place the static mesh in the world. Then go to the fracture panel and press new. After that, in uniform, we leave the settings as they are and press fracture. Then we go to the bottle to hide the fracture patterns by disabling this option. After that, we try applying physics to it. As you can see, it doesn't break easily. So we tweak it. click it and look for damage threshold and set all values to 10. Simply put, this only controls how easy it is to break. The lower the value, the easier it breaks with the first hit, and vice versa. Then we delete the old one from the world and put it again. Let's test. Good, it works nicely. Now we'll create a new actor and name it fracture underscore glass underscore bottle. Inside it, we create a geometry collection and put our fractured bottle there. Back to glass bottle. First thing is that we don't want it to break at the start of the game, so we create a variable called start action that activates after 1 second from begin play. In event hit, we check this condition we just made, then do once, then spawn actor of class for the fracture glass bottle with the same coordinates as the throwing item. Change the collision to physics only. Destroy the throwing item. Play the sound and do report sound. As for the sounds, as usual, I'll leave a download link for you in the description. We add the sound, and don't forget to finally add the tag. And we add the sound to the item tin food. And now we're done here. Now I just remembered something. We're supposed to get an error if we try it now. That's because of the way the variable is being referenced here. To fix it, simply create a variable in the character from the AI controller. Then from the character, bring the correct variable. So, as usual, we have some bugs. Looks like a sound is being played at the start, and for some strange reason, I can't pick up the bottle now. And even when I touch it, it doesn't break. Okay, let's fix this and get back to you. Alright, I'm back. The first thing I did was change the collision here and gave them a better shape. Then I added sound attenuation to make the sound feel better. I didn't change any settings. Then I placed it here when playing sounds. Then for the bottle issue, first we must adjust the damage threshold, again from inside the actor. And then to fix the glass bottle issue, I added event begin, play parent. And in tin food, I added the same logic at the start since we don't want the sound to play at the beginning. And in the parent, I added a new physical material. It's simple, just click here and choose a save location, then copy the same settings I made inside it. And another important mistake I made out of rushing. Pay attention to this. The tag must be added to the actor and not the static component. This is very important. Simply click here and look for tag. It should be from here. After that, in AI perception, I made it detect sounds from everything around it and set the time search to 8. Then I copied the same logic before the anime montage to add an extra check only. And as extra improvements, I polished the trajectory system. This is the difference between the old and the new. Simply, I deleted the front and back faces of the cylinder in Blender so it looks like this. Another fix I did was repairing the item pickup system, so you can't pick them up if you're behind a wall or obstacle. Simply, we add items to the array here and first check if we can pick it up or not before letting the code continue. As for the last fix I did, it's a common problem in Unreal Engine that sometimes objects clip through walls and stop colliding. This doesn't always happen, but in some conditions it's highly possible, so we'll fix it. To fix it, go to Project Settings, search for something called Substepping, enable it and set the value to 8. If the problem still isn't fixed, just increase this value more. I'll dedicate another video to explaining how to fix such physics issues. For now, just enable this option. And that's all the changes I made. Now, let's do a full test for everything we built. We pick up our items and then head to the AI, and as a start, let's try throwing the bottle. We select it from the throwing widget we made. Yes, amazing. Exactly how we wanted it. When we throw it, it breaks, and the AI goes to the sound source, plays the searching animation, and after finishing, goes back to its place. You can also do even more creative things. For example, you could throw something at a bottle far away, it breaks, and the AI goes to check the sound. Or even when the player walks over the bottle and it breaks, the AI notices and heads toward him. There are endless possibilities in what we showed today, and it's all up to you to decide how to use it. So, I'll see you in the next video where we'll build the stealth system in the grass.